I went out to Home Depot and Lowe's and picked up a wide range of the most common filters homeowners are buying right now. We've got everything from basic, inexpensive filters all the way up to high-end filters that claim they stop bacteria and viruses. Here's what we're testing. From Filtrete, we're testing their 300, 1085, 1500, and 1900 filters. From Home Depot's brand HDX, we're testing their FPR 5, 7, 9, and 12 filters. And from Flanders, we're testing a MERV 8 pleated filter and even a MERV 1 filter. Now, most people think the job of an air filter is simple. Just clean the air in your home. And that's true to a point. But the primary job of your system's air filter is actually to protect the equipment, specifically the coil. The coil is the heat exchanger in your system. It's what removes heat from your home in the summer and helps bring heat in during the winter. If the coil gets clogged with dust and debris, airflow drops, efficiency goes down, and your system has to work a lot harder. And on top of that, all that buildup can create the perfect environment for things like mildew, bacteria, and mold to grow. The marketers for filter companies chose to focus on the filter's impact on your home's indoor air quality because that's what matters most to homeowners. Your system has to pull air through that filter every time it runs. And the more restrictive that filter is, the harder your system has to work. Think of it like breathing. A basic filter is like breathing normally, but a high filtration filter can be like trying to breathe through a thick blanket. So instead of just guessing which filter is best, we're going to measure it. We're running a static pressure test on every single one of these filters to see exactly how much resistance each one adds to the system. Because here's the real question. Is the filter that cleans the air the most actually the best filter for your AC system? Or could it be doing more harm than good? Let's find out. So before we jump into the results, let's just talk a minute about how air filters are actually rated. The most common rating you'll see on an HVAC filter is something called a MERV rating. MERV stands for Minimum Efficiency Reporting Value. This rating system was developed by the American Society of Heating, Refrigeration, and Air Conditioning Engineers, or ASHRA, and it means a filter's ability to capture airborne particles. MERV ratings range from 1 all the way up to 16 for residential and light commercial applications. Now, when we talk about particle size, we're talking about really tiny particulate. A human hair is generally around 50 to 100 microns in diameter. Some of these high-rated filters are designed to capture particles down to 1 micron and even smaller. So naturally, a lot of people, including HVAC technicians, assume the higher the MERV rating, the more restrictive the filter is going to be. And honestly, before doing this testing, I would have generally agreed with that statement. But what we've discovered during this test was a lot more interesting than that. Now, before we look at the filters themselves, let's quickly talk about static pressure. In simple terms, static pressure is resistance to airflow inside the HVAC system. Your blower motor has to push air through ductwork, through the evaporator coil, and through the air filter. Every component in the system creates some resistance. And the harder it is to move air, the harder your equipment has to work. Now, for this test, I'm not focusing on total external static pressure. Instead, I want to isolate one variable, and that's the pressure drop across the filter itself. In other words, How restrictive is each filter? Every filter in this test was installed in the same system, in the exact same home, and tested in the same way. So while these results may not perfectly match your home, they do give us a really good apples-to-apples comparison between these filters. Now, let me let you in on a little behind-the-scenes information. I conducted this test 2 times. The first time I did the test was on a system at the Greens Energy Services office. And this is the footage that you're going to see in all the B-roll today. Once I got done testing all the filters, the results I was getting seemed a little off to me. We have a number of Amana S-Series heat pump systems installed at our office. And I didn't know this, but the fan in this system automatically adjusts to overcome static pressure. So normally, when you pull up the rated indoor airflow chart for an air handler, you will see that the CFM changes as the static pressure rises. With the Amana S-Series, your cubic feet per minute literally remains the same, whether you have 0.1 static or 0.9 static. And that's something to think about if you're in the market for a new heat pump system. All right, let's get into the results. First up is the Flanders Easy Flow 2. This is the only fiberglass filter we tested, and honestly, this thing is about as basic as it gets. It's a MERV 1 filter, designed to capture only the largest particles. I paid about $4 for it, and structurally, it's pretty flimsy. Actually, I couldn't even find this filter in the exact size I needed, so I bought a larger one and cut it down myself, which definitely didn't help the rigidity situation. You can see my tape job there. Here's my honest opinion on this filter, though. If I can read my mail through this filter, how much dirt and debris is it actually capturing? Now, to be fair, it absolutely excelled in one category: airflow. This filter had the lowest pressure drop of the entire test at just 0.04 inches of water column. So yes, it flows air extremely well, but that low restriction comes at the expense of filtration performance. Next up is the Filtrete 300. This is a MERV 5 filter, and it uses electrostatically charged polypropylene media. Basically, the filter material is designed to attract airborne particles. This filter came in at around $6, but structurally, I found it still somewhat flimsy. Now, here's where things started to get interesting. Despite only being a MERV 5 filter, the pressure drop jumped to 0.22 inches, and that's a pretty significant increase compared to the fiberglass filter we just tested. And remember that number, because later in this video, we're going to test filters with much higher MERV ratings that actually produce lower pressure drops than this one did. Next up was the HDX FPR 5 filter from Home Depot. This is rated as a MERV 8 filter, and interestingly enough, it actually performed better than the Filtrete 300 in terms of airflow restriction. I measured a pressure drop of 0.17 inches across this filter. Now, one thing I noticed about the HDX filters is that the filter isn't nearly as rigid as some of the higher-end Filtrete filters we'll look at later. And personally, that matters to me, because as a filter loads up with dirt and debris, over time, a flimsy filter increases the chance of air bypassing around the media instead of going through it. Next up was the Flanders Natural Air Filter. This is also a MERV 8 filter, and I'm going to say, as far as rigidity, it's about the same as the Home Depot filters we tested. This filter is marketed as an odor-reducing filter because the media is treated with baking soda. But despite the stronger construction, the pressure drop increased quite a bit. I measured 0.30 inches across this filter, That's almost double the restriction of the HDX MERV 8 filter. And this is where we start seeing something important. MERV rating alone doesn't tell the whole story. Filter design matters. Pleat spacing matters. Surface area matters. Now let's move into the mid to high filtration filters. The HDX FPR7 is marketed as an allergen plus filter, and depending on where you look, it's either labeled as a MERV 10 or a MERV 11. Even the packaging in the website didn't seem to agree on what the MERV rating was on this filter. This filter had a thicker media and was electrostatically charged, but again, I still found it fairly flexible structurally. The pressure drop measured 0.29 inches, and then we tested the Filtrete 1085. This is where Filtrete really started separating itself from the pack. This MERV 11 filter uses a tighter pleat spacing and a better construction than the filters we've already tested. And despite being a higher rated filter, the pressure drop came in at 0.28 inches. That's slightly lower than the HDX filter we just tested. Then we tested another Home Depot filter, the HDX FPR9. This is also a MERV 11 filter, but this one produced a pressure drop of 0.32 inches. So at this point in the testing, the trend has become pretty clear. Not all filters with the same MERV rating perform the same, not even close. And then we got into the filter that completely challenged my expectations. The Filtrete 1500. I'm going to be honest with you here. I know experienced HVAC technicians who tell homeowners never to use filters like this because they believe high MERV filters are automatically too restrictive. But the results from this filter genuinely surprised me. This is a MERV 12 filter with dramatically more pleats than the lower end filters we tested. I counted roughly 56 pleats across the filter compared to around 20 pleats on many of the other ones. That means significantly more surface area for air to pass through. And the result? The pressure drop of just 0.21 inches. Think about that for a second. This MERV 12 filter actually outperforms several lower rated filters in airflow restriction. And that was probably the single biggest surprise of the entire test. And then we tested the HDX FPR 12, and things went completely the other direction. This is a MERV 13 filter, marketed as an ultimate allergen filter. But the pressure drop across this filter measured a staggering 0.72 inches of water column, just across the filter alone. To put that into perspective, many residential HVAC systems are designed to operate around 0.5 inches of total external static pressure for the entire system. This filter exceeds that number by itself. Now listen, what you choose to install in your home is entirely your decision, but personally, I wouldn't run this filter in my own system. And finally, we tested the Filtrete 1900. This was the highest rated Filtrete filter I could find locally, and honestly, after seeing the results from the 1500, I was extremely curious how this one would perform. Like the 1500, it uses a very dense pleat design with a tremendous amount of surface area, and once again, the results surprised me. This MERV 13 filter produced a pressure drop of just 0.24 inches. That's dramatically lower than the HDX MERV 13 filter we just tested, and honestly, I think this test demonstrates something really important. The lesson here is not that everybody should immediately run out and buy the highest MERV filter they can find. The lesson is that airflow restriction is more complicated than the number printed on the box. Filter design matters, the pleat density matters, the surface area matters, construction quality matters, and if you're trying to balance good indoor air quality with good HVAC system performance, you need to look deeper than just the marketing claims or MERV rating alone. Now, I'd love to hear from you. One thing we didn't test in this video is how these filters behave over time as they begin loading with dirt and debris. Because a filter that performs great when it's clean may behave differently after 30, 60, or 90 days of operation. So if you'd like to see us tackle a long-term filter loading test in a future video, let me know down in the comments. Also, let me know, what filters are you currently using in your home? Have you ever noticed airflow issues after changing filters? Put that down in the comments. And if this video helped you, make sure you hit the like button, subscribe to the channel, and I'll see you in the next one.